Hey, this is Rohan and welcome to this tutorial on question 9, week 8. The question reads, an organization monitors many aspects of elementary and secondary education nationwide. Their 1984 numbers are often used as a baseline to assess changes. In 1984, 19% of students had not been absent from school even once during the previous month. In the 1988 survey, responses from 7,438 randomly selected students showed that this figure had slipped to 17.5%. Officials would note any change in the rate of students' attendance. And we have 4 questions that we are asked to answer. The first one is, we want to write appropriate hypothesis. The first one is the null hypothesis, which speaks to what is assumed to be the case and what is status quo. And we are told that the 1984 figures form the baseline, so the reference is going to be to this 19%. So the percentage of students in 1988 with perfect attendance the previous month is equal to 19%. That's going to be our null hypothesis. The alternative hypothesis, which is what we would want to use the data collected to prove, is that the percentage of students in 1988 with perfect attendance the previous month is not equal to 19%. Now please note that we are using not equal to 19% because we're interested in seeing if it's different from 19, which includes it could either have increased or it could have decreased. Because the percentage we got in the sample is 17.5, one may tend to think that we are interested in only that direction, but we are not. If you look at this graph, if this middle region was 19%, we would want to know if it falls anywhere in this lower tail or this upper tail, and therefore we are interested in the alternative hypothesis being that it's not equal to 19. Part B is asking us to check the necessary assumptions. The first one is that we're going to assume that there's independence. The data doesn't provide enough information for us to really check that, but there is no reason to think that students' attendance records are not independent of one another. The second one is the random condition that is asked if the data were randomly selected, and proper randomization can ensure independence. So the randomization condition is satisfied. The 10% condition is also satisfied because we're assuming that the number of students in the country are super large, and the sample isn't going to be anywhere near to 10%, but it's going to be way less than 10%. Success failure condition requires that at least 10 successes and at least 10 failures must be expected in the sample. The proportion for the population is 0.19, so therefore assume the null hypothesis and find the expected number of students with perfect attendance in 1988. So if you multiply 0.19 by 7,438, we would get 1413. The value for Q0 is going to be equal to 1 minus P0, which is 0.18. So likewise, the expected number of students without perfect attendance in the sample is going to be that 0.81 times 7438, which is 6025. Since both numbers are greater than 10, the success failure condition is satisfied. So all 4 conditions are satisfied. Next part, we want to perform the test and find the p-value. Now, because there are several ways to do this and there is preference to using certain methods and there is opposition to using certain other methods, to make sure this covers all possibilities, I am going to use 3 different ways of doing it. First of all, I'm going to use a mix, which is a manual way to calculate z, and z can be found from this expression here. I extracted the information. N is 7438, p hat is 0.175. The successes therefore is equal to p hat times the sample size, the population size, just to show you how we got the number of successes. P naught is 0.19 and Q naught is 1 minus P naught, which is 0.81. So this expression, if you look here, what I have done is plugged in all the values here so that I can find a value for z. Now, once I've found a value for z by using this equation, then this website here allows you to plug the value in, and the value is minus 3.30, and you hit compute p and it spits out the z value given. It spits out the corresponding p value for a two-tailed test, and therefore it allows you to, as simple as that, know what the p value is. This actually is the z value, and the corresponding p value we found from using the website was 0.001. Alright, so that's the first of 3 methods. The second method I want to show you, this is the result using what we call StatCrunch, which is a part of the package that you have access to in MyStatLab. If we are here and we're in the midst of a question, we can hit StatCrunch and it comes up here, and just to make sure that I can see the data at the same time so that I can do this for you. So what we're going to do, we're going to use stat. We want to perform a proportion stat analysis, and it's going to be a 1 sample, and we do have the summary. So it's a series of choices there based on what we are asking StatCrunch to calculate. The number of successes we type in as 1301, and also the total number of observation 7438. The p-value in this case is 0.19, and the alternative hypothesis is that p is not equal to 0.19. Then you hit compute and it spits out that information. So that's the process. So let's get back to the result as I have it here displayed in the Excel document that's attached. It shows us the p-value. Now the third method is using PHStat, and this is the result of using PHStat. So you have PHStat downloaded on your machine, you hit PHStat, you want to do a 1 sample test, and it's going to be a z-test for the proportion. You're going to hit on that and it populates this input window. The null hypothesis pivots around 0.19. The level of significance, we're going to use 95%. The number of items of interest, number of successes was 1301. Our sample size was 7438. And we are doing a two-tailed test because we're interested in if it's different than 0.19, which means it could be greater than or it could be equal to, I'm sorry, it could be less than or greater than, and both of those would disprove the null hypothesis. So therefore we're looking for a two-tailed test. Then we are gonna hit OK, and Excel is gonna generate a sheet for you which has the results, and the results were copied here for you, and it actually hastens to the conclusion as well. After calculating sample proportion, standard error, it calculates the z-test, and it calculates the lower and upper limit as well as the p-value. So that's the three different methods of calculating a p-value. Now, in this case, the p-value, if you were to round this to 3 decimal places, it's gonna be, the calculated p-value is 0.001, which is less than the significance level alpha, which is 0.05. So therefore, if the p-value is larger than 0.05, there is not sufficient evidence. But in this case, the p-value is smaller, so this means that there is sufficient evidence to warrant a rejection of the claim. So therefore, we are going to reject the null hypothesis. Alright, so it means that we are going to accept the alternative hypothesis and say that the proportion has changed from 19%. Alright, I know it was a little bit much and it was involved. The steps I took are longer than you will need to take because I showed you multiple methods, but I felt that I needed to do that to cover all bases in terms of the different choices that you have to use to calculate the p-value. So hope you found this useful, and if you have any questions, feel free to reach out to your tutors and or your teaching assistants, and we will be more than happy to help you. Alright? Thank you.